Welcome. In this video, we're going to show that the limit as t approaches 0 of t squared times sine of 1 over t is equal to 0. We're going to do this by using the squeeze theorem. So first, let's try to squeeze a sine of 1 over t between two other functions. And so we know from trigonometry, let me make some space here, that the graph of y equals a sine of x has an amplitude equal to a. Looking at our function, this is like multiplying a 1 right there. So a in this case equals 1. So that means this sine of 1 over t has an amplitude of 1. So it's sandwiched between -1 and 1. Okay, well, how does this help us? Well, this is where I can use some algebra. I'm going to multiply each side of this, or each part of this inequality, by t squared. So as you can see here, I multiplied the -1 by a t squared, I multiplied the 1 by a t squared, and I multiplied a sine of 1 over t by t squared. Okay, so the leftmost side is -t squared is less than or equal to, and then in the middle here we have t squared sine of 1 over t, and then on the right we have t squared. So now all that's left to do is find the limit as t approaches 0 of -t squared, and to find the limit as t approaches 0 of t squared. Now remember, if these exist and are equal to the same value, that tells me, let's say this equals to L, both of them, that tells me that the limit as t approaches 0 of t squared times sine of 1 over t is also equal to L. And this is by the squeeze theorem. In short, this function is always squeezed between these two other functions. Okay, so let's start with this limit. 0 is in the domain of -t squared, so I can apply the direct substitution property and make this -0 squared, which is just 0. And 0 is also in the domain of t squared, so this is just 0 squared, which is just 0. Since the limit as t approaches 0 of -t squared and the limit as t approaches 0 of t squared both equal 0, then by the squeeze theorem, we know that this limit here, that's the limit as t approaches 0 of t squared times 1 over t, is equal to 0. Alright, before we end this video, let's use technology and just really visualize what we actually did here. So as you can see here, I opened up Geogebra Classic on my iPad. You can follow along in a browser as well. And I'm going to type in y equals x squared. We have to use x's instead of t's here. Times, and let's go to f of x here to find our function. So there's sine, and then back to numbers of 1 divided by x. So this was our middle function. And let's zoom in to see what's happening close up here. Okay, so now let's go ahead and graph y equals -x squared, and then y equals just x squared. And look at that. The limit we were interested in as t approaches 0, in this case x approaches 0 of x squared of sine of 1 over x, is completely sandwiched between x squared and -x squared. And so if I keep zooming in further and further, you'll see that no matter how far I zoom in, x squared times sine of 1 over x in purple stays between the upper parabola, which is just x squared, and the lower parabola, which is -x squared. This should also help you see why this is often called to the sandwich theorem, or referred to as the sandwich theorem. I mean, this is like the top bread of our sandwich, this is the lower bread of our sandwich, and if you're like me, this is a whole bunch of bacon and avocado in the middle. I hope this video was helpful.